Hello everyone, my name is Amy Baggett. Today I'm presenting my final project, The Calculated Consumer. This is a data-driven audit into how logistics math and algorithmic pricing strategies directly impact our household economies. As consumers, we are trained to look at the retail price tag, but after 6 years in logistics and my current work as a data analyst at MTSU, I know that price is a moving target. My project audits 2023 Amazon metadata to reveal the hidden shipping penalties and algorithmic shifts that erode consumer value. Standard market strategies rely on the consumer's inability to do math at the shelf. To counter this, I've introduced a new dimension to our dataset through feature engineering. I used the industry standard 139 divisor to calculate dimensional weight. By comparing this to the actual weight, I created the space tax percentage. This allows us to mathematically define exactly when a consumer is being charged for empty space. The 139 divisor isn't just a random number. It represents the density pivot point for major carriers. It assumes that 1 pound of cargo should take up no more than 139 cubic inches. By applying this to our dataset, we can see exactly when an item becomes inefficient in a shipping tote. When the dimensional weight exceeds the actual weight, the algorithm must account for that lost space, and that is where our space tax begins. The formula for unit price divided by weight is our primary tool for normalization. In a market where packaging sizes are designed to be misleading, the unit price creates a level playing field. It allows us to compare a small single item directly against a bulk item to see if the consumer is actually receiving a volume discount or if they are paying a premium for the convenience of the packaging. The space tax formula, dim weight minus actual weight, then divided by dim weight and multiplied by 100, is a feature I engineered to quantify the logistics penalty. It tells us what percentage of the billable weight is comprised of nothing but air. This is a new dimension in our analysis because it moves the conversation away from what the product is and focuses on how much space the product wastes. Insight 1 looks at our baseline logistical impact. Chart 1 identifies which categories carry the highest unit price density. By auditing the relationship between physical volume and retail cost, we've uncovered a significant value erosion. We can finally see where the most expensive substance is actually hidden across the catalog, regardless of the sticker price. Chart 2 confirms our sample size is statistically significant, ensuring our audit represents the reality of thousands of SKUs across the most popular departments, from small singles to non-sortable units. On the mean, our analysis shows an average space tax of 21.15%. To put that in perspective, over 1/5 of the cost for these items is purely logistical overhead. You are paying for the box and the air inside it, not the product. On the max, perhaps more alarming is our maximum extreme of 99.95%. In these severe cases, the logistical penalty effectively doubles the product cost, essentially charging the consumer for the space volume rather than the substance. On standard deviation, finally, the high standard deviation in our data identifies what I call logistics noise. Prices are highly volatile, proving that the algorithm is constantly adjusting for size tier inefficiencies rather than product quality. Chart 2 confirms our sample size is statistically significant, ensuring our audit represents the reality of thousands of SKUs across the most popular departments, from small singles to non-sortable units. On the mean, our analysis shows an average space tax of 21.15%. To put that in perspective, over 1/5 of the cost for these items is purely logistical overhead. You are paying for the box and the air inside it, not the product. on the max. Perhaps more alarming is our maximum extreme of 99.95%. In these severe cases, the logistical penalty effectively doubles the product cost, essentially charging the consumer for the space volume rather than the substance. On standard deviation. Finally, the high standard deviation in our data identifies what I call logistics noise. Prices are highly volatile, proving that the algorithm is constantly adjusting for size tier inefficiencies rather than product quality. Insight 2 is the core of our audit. When we map price against quality, we see a complete disconnect. The regression line is flat, proving that higher prices are decoupled from consumer satisfaction. You aren't paying for a better product, you're often paying for a more expensive journey through the logistics chain. By creating these variables, we've exposed that the premium price is often just logistics noise. When we look at the distribution of prices, we see a heavy right skew with a value of 3.36. This indicates significant price traps, where algorithmic surcharges push costs into extreme territory. This is evidenced by the gap between our $23 median and our $37 mean, proving that outliers are skewing the market average significantly higher than typical costs. Our summary statistics show these outliers aren't random. They are concentrated in specific logistics brackets. You can see them here as dots rising far above the average, proving that the consumer is forced to pay for space efficiency rather than product value. Insight 4 examines the logistics penalty. As shown in Chart 3, average ratings remain remarkably stagnant across all categories. This proves that higher unit prices are not buying you a better rated product. Whether you are in a high tax category or a baseline one, the consumer perceived quality remains exactly the same. Chart 7 identifies demand velocity to show us exactly where the crowd is. Our ranking table identifies grocery at a 38.14% penalty as the highest risk category. These high velocity departments are where the logistics tax is most easily applied, because the sheer volume of transactions allows these algorithmic surcharges to go unnoticed. Finally, we look at profit extraction. By plotting price against demand density in Chart 8, we see that as an item becomes popular, its price volatility increases. High volume doesn't lead to bulk savings. Instead, it signals the algorithm to test higher price ceilings. The ranking table shows exactly which departments carry the highest risk for the consumer. To conclude, here is the strategy for the calculated consumer. First, ignore the retail sticker and audit the unit price. Second, recognize air-heavy packaging as a direct tax on your wallet. By bypassing these algorithmic traps and choosing density over volume, we reclaim control over our spending. We move from being passive shoppers to informed analysts. This audit is just the beginning. The goal is to move the needle on how we perceive value. My analysis has shown that by applying data cleansing and feature engineering, we can quantify the hidden costs of our modern economy. Thank you for your time, and I am now open for any questions.